This is on the back side of your synthesis. It kind of goes with synthesis because it's, if you notice, it's the opposite of synthesis. Instead of putting things together, we're gonna break them apart, okay? So you have 5 different rules on this one, 4 different rules. Basically, number 1 is AB gives us A plus B. Pretty simple stuff, okay? So number 2 is very, very literal. Binary compounds, 2 elements. All they do is break them apart. So we're predicting products. Decomposition is probably going to be your easiest one to recognize because it's 1 reactant. And it breaks up into more than 1, 2 or more, okay? So these first 2 are binary compounds. You have 2 elements and that's it. So what they're going to do is they're going to basically just break apart. Oops, the wrong color. I was going to do it in green. Sorry. Hg and O plus O. Now, you have 3 elements now. So what do we have to do? Just like in previous videos, we have to see if we have any diatomic molecules. Since we have a diatomic molecule in oxygen, it has to have a 2. Okay? Now, you kind of have to see, because mercury is one of those transition metals, we need to know what it was. Well, since there's no subscripts here, we know that this is a 2. Okay? So now we have to balance this. So it's going to be a 2 to 1 to 1 ratio. Okay? So I didn't mean to write that one. 2 to 1 to 1 ratio. Okay? Pretty simple so far. Next one, break it down. Sodium plus sulfur. Check to see if we have any diatomic molecules. I don't see any because remember it's the magic 7, Brinkelhoff. There isn't any, so it can exist this way. So it's a 1 to 2 to 1 ratio to balance it. Binary are going to be the binary compounds are going to be the easiest to decompose. They're going to be the easiest to identify. Just split them up. Just watch your diatomic molecules and remember what your, if you have a transition metal, what the charges were in the original one. Okay? All right. So again, check your charges. All right. Number 3. This one is a little bit different. It's metal carbonates. When we have a metal carbonate, and I have a cheat sheet for you, you can look at it. Remember, you can't use it on the test. So these are, if you can get 3, you can get 4 and 5 very easily. Okay? So carbonates, metal carbonates decompose into metal oxides plus carbon dioxide. Okay? So first thing you want to do is put your metal, which is calcium, plus, and oxygen, because we're going to have an oxide, plus, and then do CO2. Calcium oxide plus carbon dioxide. Now, we have to check our charges because we built compounds, but you know carbon dioxide is CO2, so that one's okay. But calcium oxide, we have to make sure we have the right charge. We have a +2 and a -2, so we don't need anything. So calcium carbonate breaks down into the metal plus the oxygen, which is a metal oxide, plus carbon dioxide. Okay? Just check your charges, okay? Check your charges. This one worked out okay, it was fine. To balance this, looks like it's already balanced, so you're going to 1 to 1 to 1 ratio. All right, next one, predicting this product. It's a carbonate. See, I think I messed up on there. Yep, I did. Let me fix that. That should be a 3. Okay, aluminum carbonate. Aluminum carbonate. You write down your metal plus your carbonate. Sorry, take that back. Not your carbonate, your oxygen. And I know some of you are going, wait. I'm thinking ahead. I've been doing a whole bunch of videos today. Sorry. Your metal oxide. Thank you. Plus your carbon dioxide. That's what I was thinking. Now, because we built a compound, we have to check our charges. Okay, guys? So aluminum has a +3. Oxygen has a -2. So it's a 2, 3. Okay. Then you just need to check all of your stuff, and it is not balanced. So it's a 1 to 1 to 3 ratio. Make sure it's balanced. Okay. We need to do a lot more balancing because it's coming up real soon, and we'll have to do a lot of it. So please keep balancing. Make sure you have a balanced equation. All right, so that is your carbonates. Okay, if you have a metal carbonate, it's going to break down into a metal oxide and a carbon dioxide. So just remember CO2. Okay. All right, metal hydroxides, fairly simple. Okay, the rule says metal hydroxides will break down into metal oxides, just like this one, a metal oxide, plus water. So we're going to take our metal out. We're going to stick it with an oxygen, okay? And then we're going to add our water. So barium hydroxide breaks down into barium oxide and water. Now we have to check our charges. Well, it all balances out. The charges are balanced out. We don't need them. Just like up here, we're going to get rid of them. Up here. Okay, so BaO plus H2O. And I think we're balanced on this one. So it's a 1:1:1 ratio. Okay, I'm going to have a few more of these on your sheet to bring to class. But again, carbonates, CO2, hydroxides, H2O, and then the metal oxide. Okay. Number 5 is metal chlorates. So metal chlorates will break down into, maybe you'll figure it out, maybe not, but it's going to break down into a metal oxide and oxygen. I'm sorry, a metal chloride. I did that wrong. Sorry. Oh, I did do that one right. A metal chloride and an oxygen. So I did have that right. Okay, I just was reading my things wrong. Okay, so metal chlorates, it says, will change to a metal chloride. And remember, IDE stands for, you're going to the periodic table, okay, plus an oxygen. Okay, so you take your metal out and you take your chlorine out. This, by the way, everybody keeps wanting to say this is an I. It is actually an L, a lowercase l. KCl. KCl. Okay? KClO3, not KCiO3. It's KClO3. Okay? Chlor. That's kind of your hint there. Okay? Plus oxygen. And oxygen is a diatomic molecule. That's why it has that 2 there. Okay? So check your free elements and check your charges. Check your free element and check your charges. This is a +1. This is a -1. So it works out. Okay? This was a short video. You'll have a couple of examples, and then I have some on there that are mixed up between synthesis and decomposition. So make sure you do those and bring them to class. Okay?